on this ranch locally and kind of set the context for the state, the day. But when it comes down to it, I mean, we know that you guys are super, super busy. We really appreciate you being able to spend a little bit of time with us, hearing about some of the stuff we've been working on. We hope some of the information is going to be useful. And I just really appreciate you guys being able to spend a few hours with us today. So just to set the stage for the day. So we have this concept of a drying climate on rangelands, right? So what does that really mean? Is it just drought, or are there other things we need to be thinking about? This graph is a little busy and a little hard to see. I actually have copies. This is not a paper I did, but this is a really great research paper that's published in 2015. I'll put some copies in the back if you guys want to spend a little more time at it. But I think if we break it down a little bit, the picture it paints is pretty clear and gives us a context of really what we're talking about today. And throughout most of our professions lately. What we have here is these researchers went back and it's not working. Went back and looked at all the data, the precipitation and temperature data in California over the instrumented record, right? So that's well over 100 years of data. And they took, and this is for the entire state, so it's just not Northern California, not Southern California, it's the entire state. And what they asked is for each year, how did that year deviate from average? And a lot of times when we talk about averages, we're talking about anomalies. You see that word used. So here, what they are expressing is a precipitation anomaly on this axis here. And so on this side of this axis, it's a dry anomaly, so this is up to 30 inches below average. On that other side, it's up to 40 inches above average. And then on this vertical axis, it's temperature, so all the way down from minus 2 degrees Fahrenheit below average up to 3 degrees Fahrenheit above average. And the way the researchers lined this out is actually a really nice way to look at it. You know, they made it really simple for us to kind of look at these patterns. So if these anomalies for each year deviated in terms of like dry and hot, it's sort of in this quadrant. So if it was not only just a dry year, like limited precipitation, but really hot, they fall in this quadrant. If it was a hot year, but fairly wet, it's over here. If it's dry, but cold, kind of in here. And these are, again, all relative to average. And if it was wet and cold, it's here. And again, this is over 100 years of instrumented data. And sort of the basis of this paper is to look at this 2014. So we all sort of, that's not too far in our recent memory, right? We kind of remember what 2014 looked like. And they asked, where did 2014 fall in this anomaly on between dry and hot? And what this evidence points to, the 2014 was really the driest and hottest year that we had in the instrumented record, right? And most of us, that's not too far back, will remember that. But to dig a little bit deeper, what I did is I went through and circled what the last 10 years from 2014 looked like, right? And I know it's hard for you guys to see the numbers from here, but that's where the circles are. So this is everything from 2014 to like 2001, I think. And we can see in all of those years, most of them were in this dry, hot quadrant, and there was a few in this wet, hot quadrant. So what we're seeing is that, you know, it's not just lack of rainfall that we're talking about when we talk about things like drought and a drying climate, but a lot of it is this temperature signal here, right? So most of these years weren't just dry, but they were also really warm. If we look back, it's a little hard for you guys to see probably from where you are, but if you guys want to look back on like the 1987 to 1992 droughts, we're also in here. In fact, to find any years that were cooler than average I've looked at this, we need to go back to like 1978, right? And if we look at the 1977 drought, you guys looked a little bit into sort of the hydrologic history of droughts in California. That was a pretty extreme drought. That had about the same amount of limited precipitation. So if you look at 1977 from 2014, about the same level of anomaly, but look, it was a much cooler drought, right? So this is kind of like the main thing I just wanted to have you guys look at before we kick off the day. So it's not just lack of rainfall that we're talking about, but it's really how do temperatures overlay into that lack of rainfall for each year. Just to give you some practical pictures, so we have a 6,000 acre ranch. We have a good number of animals we graze each year. This is what our rangeland looked like during that 2014 drought. In fact, if we look at our records for December 2013 to January 2014, we had less than an inch of rain here. We collect forage data regularly every month. Normally, we should be around 500 pounds of feed per acre in our pastures. This particular year, we're at 50 pounds. So a lot of you folks that work with ranchers or have been ranching probably saw something very similar regardless of where you were in the state. This shows you a few more years of our forage production. So like I mentioned, we clip and measure the amount of grass and forage growth monthly during the growing season. You can see those month intervals down here. We measure forage production in terms of pounds per acre. Average, we typically by the end of the year are around 3,000 pounds. This dotted red line shows you our average trend over 20, 30 years of clipping data. And you can see we get most of our growth, just as you expect, during this sort of March-April period, kind of peak out around 3,000. This was at 2013-2014 year. We had about 55% of our rain, but we still grew 2,000 pounds of grass. So even though that grass growth didn't start until well into February, almost March, it was a very short growing season. We were able to catch up because of the timings of those rains. Just as another example, this black line here was 2017-2018. We had about 90% of our average rainfall, so it wasn't necessarily a banner year on precipitation, but we grew over 5,000 pounds of feed. In fact, we grew so much feed that year, we didn't even have enough animals to graze it all down, and we had some problems managing our thatch for the next year. Just going to show a little highlight on this real quick. This is some research that was done here that I thought was really intriguing. I'm going to show you just really this picture. The data kind of back it up, but I'm not going to go through each of these data points with you. But what these researchers did here with some projects here is they asked, we know how leaving things like residual dry matter or thatch, that influences the amount of forage we grow next year. We know that, we've known that for many decades. But what these researchers are really interested in is looking at legacy effects from the previous year. So not asking how does our residual dry matter or thatch this year and our rain affect the forage I have this year, but what about last year? And through a really nice series of manipulations, what they did is they manipulated fall rain, winter rain, and spring rain the year before, and they asked how those inputs the year before influenced our forage production the next year. And what they found pretty strikingly is that the rainfall last year, the amount of rainfall you had last year can influence your forage production this year by 10 to 20%, just depending on what happened last year. And it wasn't necessarily just how you managed your thatch and residual dry matter, but what the seed bank was doing. So in really droughty years, as your seed bank becomes more dominated by things like fillery or other forbs that are fairly nutritious but not very productive, as those seed banks become more dominated by those species and less by grasses, your forage production can drop 10 to 20% just because of the legacy effects from last year. So I throw this up just to kind of paint sort of the spectrum of sort of variation that we're looking at. It's not just more rain is going to make more grass, right? We need to think about not only how we manage the pastures now, but also what happened last year. And probably there's many more complex interactions that we haven't even explored yet. So I want to just kind of point this out real quick, and then we're going to turn it over to Dr. Bird here to talk more about her work. But we've been collecting data, like I mentioned, for many, many decades. So this is a really nice resource for you guys to kind of see what happened in the past and see what may be going on currently and down the road. We can go back and look at this database we have, and we see that 1987 here locally was our worst forage year on record. We only grew 1,000 pounds of feed, so it's like 30% below our average. But we had 20 inches of rain, which is more rain than we had in 2014. So we grew way more grass in 2014 with less rain than this year. Our highest rainfall, you guys remember a little bit about what went on with flooding and everything in 1997, regionally in Northern California. We had 3 gigantic Pineapple Expresses that came through. We got 50 inches of rain. But this amount of rain actually decreased our forage production, significantly. We lost about 500 pounds of feed per acre by having too much rain. And then again, in 2017, we had average rain, but we had a record-setting amount of feed that we've ever seen. So obviously things like timing of rainfall, duration of rainfall, what this means for time and duration of forage are going to be important. And these are some of the things we'll be talking about today a little bit more. I wanted to point this last little link out to you. If you go on our webpage here, so let's see if this works. And you can find this link on our webpage, but this is basically a nice little interface to look at all those data I was just talking about. So what you can do here, there's a little simple toggle bar where you can look at, it's not even going on the screen, so. Well, shoot. See if I close that out. There we go. Okay, so I just clicked on that link. There's a little toggle bar here. You can look at production and precipitation relationships. You can look at production and soil temperature relationships. And you can enter any year you're interested in. So like if we want to go back to like 1987, we have less of the monthly data in this, but we can see things like, that's not the one I wanted. We'll look at the production and precipitation. So we can say, okay, we know 1987 was one of our worst forage years. What happened with rainfall just locally? And shows us a couple years here. The red bars are historical average, and then the bottom graph is just what happened with rainfall. We can quickly see that it just didn't rain at all, hardly any of these months. So 2014, we actually had a good amount of rain, sort of our spring months. We didn't really pick that up in this 1987 period. So if you're interested in sort of what things happened in the past, what's going on in terms of precipitation and forage production in this part of the state, really easy tool for you guys to find on our webpage.